Hey everyone, welcome back to the channel and I hope you guys are doing extremely well. So today we are going to solve a very important graph problem that is called number of enclaves. This problem is totally based on DFS or BFS on grid and it has a very common interview pattern. So if you have solved a problem like surrounded region, which we have already solved in the previous video, so make sure to watch that video first and then try to solve this particular problem. So this will feel a continuation of that particular problem. So without wasting time, let's get started with this brand new question, brand new important question, number of enclaves. So before moving towards intuition approach and dry run, let's understand the problem statement first, what the problem is saying. We have a 2D grid. 1 represent a land and 0 will represent water. Now our task is to count the number of land cell that cannot reach the boundary of the grid. In simple term, if a land cell can walk off the grid boundary, it is not an enclave. If it is completely surrounded and cannot reach the boundary, it is an enclave. So I know this statement is heavy, so let me simplify it first. This means we need to convert all that 1 into 0 which are at the boundaries. Okay, that means we need to convert this 1 into 0, and after that we need to check in all the 4 direction of this one, means upward, downward, right and left. And if there will be any one in the direction, we need to convert that one into 0. Okay, this is very similar kind of surrounded region. In that problem, we need to track O at the boundary. If there will be any O, we need to mark it as safe. But in this problem, we need to mark it as 0. Okay, so and after that we will keep a count variable to count the remaining number of ones. This is what problem is saying. Okay, so what will be like your thought process? What will be a brute force approach for solving this particular problem? A brute force approach would be to check for every cell whether it can reach the boundary. That means we need to check for this, for this, for this, for this, for this, and for this, so and so on. For every one we need to check whether it can reach the boundary or not. So it will be inefficient approach. So as similar in previous video we used a reverse thinking, so similarly we will use a reverse thinking approach here. Instead of checking for every cell, we will traverse the boundary cell, and whenever we will find any kind of one at boundary, we will mark it as 0, and also we will traverse its adjacent node. Okay, so what will be your approach? Like, what will be your optimal approach for solving this particular problem? So let me discuss it first. Firstly we will traverse the boundary cell, first row, last row, first column and last column. Okay, whenever we find a land cell on the boundary, we will run DFS. We are solving this particular problem with the help of DFS, so we will run DFS and we will mark all the connected land cell as a 0. That means we need to make it as C cell. Okay, after removing all the boundary connected land, we will traverse the grid again, count the remaining one. That will be the approach for this. So let me start the dry run. Okay, so what we will do, firstly what we need to check, we need to traverse the boundary cell. So for this For traversing the boundary cell, what we need to do, we will start from int I is equal to 0 till n minus 1. What we will do, we will check if grid of I and 0 equal to 1, then what we need to do, we need to call DFS for 0 comma I comma 0 comma grid. Okay, cool. Also we need to check for the last column. This is for the first column, and now we will check for the last column. Grid of I comma m minus 1 equal to 1, then what we will do, we will call DFS for I comma m minus 1 comma grid. Okay, cool. So let's start. For example, put I is equal to 0. Grid of 0 is 0 comma 0 is 1. No, it's not. So it means it's safe. Grid of 1 comma 0 is 1. Yeah, it's okay. Okay, we will call DFS. And after that, grid of 2 comma 0, no, it's not. That means it's safe. Grid of 3 comma 0, no, it's safe. So we don't need to do anything. Similarly, grid of 0 comma m is 4. 4 minus 1 will be 3. So grid of 0 comma 3 is equal to 1. No, it's safe. Similarly, we will check for this, we will check for this, we will check for this, and we will check for this. Okay, that's cool. That's great. Okay, but we find that grid of 1 comma 0 is 1. So what we will do, we need to call DFS for this. So let me call DFS for this. So let me call DFS for grid of DFS for 1 I is 1 0 in grid. Okay, here firstly what we will do, we will check the boundary condition. I should be greater than 0, I should be less than equal to m, sorry, less than n. J should be greater than 0, J should be less than greater than less than n m. Okay, great. Also grid of I and j equal to 0. Then what we need to do, we will return from here. This is invalid condition. Okay, great. And after that, if this condition is not satisfying, then what we will do, we will mark grid of I and j equal to 0. That means if grid of ij is 1, then we will mark it as 0. And also what we will do, we will check all the 4 direction of this particular. So for checking or checking all the 4 direction, what we will do, we will, for upward, we need to add we need to subtract 1 from I. Okay, that means I is 1, we need to subtract 1. I minus 1 is equal to 0, 1 minus 1 is equal to 0. So we will go for the first row. Okay, for downward we will add 1. For left we will subtract 1 from the column. For right we will add 1 from the column. So you can see there isn't any kind of 1 in all its adjacent direction. So we don't need to do anything. Simply what we will do, we will mark it as 0. So let me mark it as 0. Okay, done. Similarly, what we will do, we will check for the row. For the row, what will we do? We'll start from for int j is equal to 0 till m minus 1. What we will do, we will check if grid of 0 j equal to 1, then what we will do, we will call DFS for 0 comma j comma grid. Cool, that's great. Also for the last row, what we will do, we will check grid of n minus 1 j equal to 1, then we will call DFS for this, DFS of n minus 1 comma j comma grid. Okay, done. Put j is equal to 0 here. 0 comma 0, it's 0. J is equal to 1. 0 comma 1, it's 0. J is equal to 2. 0 comma 2, it's 0. Okay, safe. 0 comma 3, it's 0. Safe. Okay. N is 4 and minus 1 will be 3. Put j is equal to 0. 3 comma 0, safe. 3 comma 1, safe. 3 comma 2, safe. 3 comma 3, safe. So we don't need to do anything. Okay. That means we will we traversed all the boundary cell. Okay. After that, what we need to do, we will iterate over this grid. Firstly, we will take a count variable, and after that we will iterate over this grid using for int I is equal to 0 till n minus 1. Okay. Similarly, for int j is equal to 0 till m minus 1. Okay. What we will check, if grid of I and j equal to 1, then count plus plus. Okay. And in the last, we need to return the count. Okay. Start from the 0 comma 0. Is this 1? No. 0 comma 1? No. 0 comma 2? No. 0 comma 3? No. So okay. 1 comma 0? No. 1 comma 1? No. 1 comma 2? Yes. So increase the value of count to 1. Okay. 1 comma 3? No. 2 comma 1? 2 comma 0? No. 2 comma 1? Yeah, it's, so increase the count by 1. 2 comma 2? Yeah, it's, so increase the count by 1. 3. 2 comma 3? No. 3 comma 0, 3 comma 1, 3 comma 2, 3 comma 3. No. So the final answer will be 3. That means there is total number of 3 enclaves here. Okay. I hope you got the logic, you got the dry run, and you got the approach. If you got it, comment understand if you understood. Okay. So I hope you got it. So let me write the code first, and after that we will check whether my code is working fine or not. Okay. What we will do, everything is clear actually. We will start from the int I is equal to 0, I is less than n minus n, I plus plus. We will check if grid of I 0 equal to 1, then we will call DFS for grid. Okay. Similarly, for the last column, what we will do, okay, similarly for the first row and the first column. Okay, let me implement the DFS function first. Void DFS. Okay, you got the logic of DFS function. Okay, it's cool. Now let me implement int count is equal to 0. Okay, we will iterate over the grid, and also we need to return the count. Okay, so okay, save it and run it once to check whether it's working fine or not. G++. Okay, 4 cross 4. So let me let me check a good test case for this particular problem. Okay, we will go through with our test case. It is okay. Okay, we got the correct output, so that's the correct code. And also a very important news for you that I have included a spreadsheet of more than 10 to 12 um, graph based DSA questions. The link is in the description, so please check it out once and start solving that problem. This will help you during your interview. So coming to the time complexity and space complexity of this particular problem, the time complexity will be n cross m because each cell is visited at most once. Okay, the space complexity will be order of n cross m. In the worst case, due to recursion stack, if we use DFS, it will queue space instead. Okay, so the key idea is instead of finding enclave directly, we eliminate all the boundary connected land first. The remaining land cell are the number of enclaves. If you have, I hope you got the logic, you got everything. If you found this explanation helpful, make sure to like the video and subscribe to the channel for more DSA content. Next, we will cover another important DFS or graph based problem. Till then, keep coding, keep sharing. See you in the next video. Bye bye.